Our next speakers are Yonggang Cao and Jiwei Cao from Outreach, a platform that encodes and automates sales activities into workflows. Continuous integration and continuous deployment are widely adopted software engineering practices. Our next speakers describe how they approach CI/CD in the context of ML. Please welcome Yonggang and Jiwei from Outreach.
Hello, everyone, and thanks for watching. Hope everyone is doing great, staying at home. I'm Yonggang. In this talk, Jiwei and I will introduce our CI/CD work in Outreach for ML service. We will start with a brief overview of our company and our team, and Jiwei will lead us dive into our CI/CD pipeline with some details, and then I will bring up some special consideration we did, and finally we will conclude with some future work. Outreach is a sales engagement platform which is powering more than 3,000 customers. Sales engagement platform in a nutshell is to enhance salespeople's sales tools like Salesforce and phone call, email, content management system, and more. So we organize all those sales activities into sequence, as you can see. So our work is basically to bring the automation and the intelligence into activities of each sequence to make the salespeople more efficient and more effective. This science arc is illustrated by this flywheel. So we start and stop with data, which we call as a situation here. And we collect relationships between people, email, phone call, calendar invite, etc., as knowledge assets. And then we build models and apply the models as the insights or give assistance to salespeople. And then we gather the usage data from the salespeople. And then we feedback to detect more situations. So as you can see, for this part, we want to speed up this cycle by building a more solid platform. CI/CD is one important part of it. Next, Jiwei will dive into the CI/CD pipeline, which is powering our NLP BERT model. Jiwei?
Yeah, so first, MLflow is an open source tool to manage the ML lifecycle, including experimentation, reproducibility, deployment, and a central repository. So in Outreach, we use a lot. So we're leveraging help of the ML projects to standardize the source code in GitHub of each ML project. We use the Databricks runtime to train and log models to MLflow experiments. After the model has been trained and validated, we want to deploy MLflow model into several locations like Kubernetes, ML SageMaker, and Azure. So I want to talk about how we structure our ML project in practice. So here is a basic example for ML project. First, the ML project is the format introduced by MLflow to describe steps and links to the Kona environment. Each ML project contains an ML project file, which identifies the dependencies, entry points, and parameters. So all the dependencies are actually specified in the Kona.yama file. So our dependency include both public packages like MLflow, scikit-learn, cache tools, as well as internal packages. So we use MLflow API to trigger Databricks runtime to run training. So we need to properly enable Databricks to read internal packages. So the next slide, I'm going to talk about how we handle the credentials like Databricks token, GitHub token. Especially, we don't want to put any tokens into Docker image or logged cont.yaml file. So here, as an example, all the packages start with a DS, actually internal package. I'll explain how we handle that in the next slide. So we come up with a solution to have like a cont template file, which contains a GitHub token as a mask. So when we're at the runtime, we build the Docker image to deploy. So we read the token from environment variables and get GitHub internal dependency. We build the Python wheels and put it into the Docker image. And in cont file for deployment, we actually put a reference to wheel files in the Docker image. So you can see from the slides here, now with all the Docker image and also the cont file, which contains internal references, we can deploy it to the ML models to endpoints like SageMaker. So next, I'm going to talk about the continuous integration and continuous delivery for ML service. There's a vague boundary between a CI and CD. So we set the boundary with the CI to have the Docker image and ML4 logged models ready for deployment. So for every checking from internal dependencies, we run integration test for a small sample of data, including and run all the steps, including model building, ML4 logging, Docker image building, push, and also deployment test. So we use Circle CI in Outreach, and we trigger a full model building before the actual deployment. So after model building, so we signal deployment pipeline to start. So ML service deployment is a combination of ML models and the service configurations. So we define a deployable version to include ML models and Docker image, and service configurations like AWS region, instance count, instance type, and also deployment version contains actual code for doing deployment, such as the code for pipeline, the code for deep ping, regression test, and load test. So we also developed mechanisms to promotion and rollback strategy, which also use the ML flow registry and S3 to track all the model and image URLs.
Thanks, Jiwei. As you can see, we have many steps in the CI/CD pipeline. Here, I want to highlight some of the special considerations. One thing we do is that we actually transformed our PyTorch model into scikit-learn model format by introduce a wrapper. Actually, we can do more than that. In the wrapper, we customize our interface by embedding the metrics, some log information, tracking information into it, as well as we added caching into the wrapping step. As you see, we do sampling in the CI step. Actually, we are using stratified sampling for the CI to have the full coverage for all the labels. And we did parameter parsing for both CI and CD. In the Circle CI environment, we use the local file-based parameter parsing. And for the CD, we use the GitHub SHA and S3 file for the parameter parsing and the triggering. When we try to use the ML flow model registry, we found that actually the registry itself don't contain slots for actual metadata, such as the image URLs. But then we figured out to use the run ID. Basically, you can see from here there is a link to the ML flow run, which can contain whatever metadata you want to put into. So we use this to associate the model with additional metadata. In terms of tests, we use mocked test for doing those interface tests to verify interface and the caching logic, as I mentioned, without any real model file or endpoint. As you can see from this screenshot, it could be a very simple fake model. And we do have additional step, as Jiwei mentioned in CD, we call it the regression test, which is after the staging deployment and before we promote to prod, we want to guard against the endpoint by evaluate both its quality and the latency. Then we collected the telemetrics from the application side. It's kind of like the clickstream, but some actions we can turn it into online test. For example, if people change our predicted class into something else, that could be a false positive of the original class and false negative for the chosen class. So this is kind of an online test we did. Of course, last but not least, we need to deal with all kinds of unnoticed traps from different tools. For example, MLflow CLI don't support sync call if you run it locally and trigger a Databricks job, it will return immediately. And SageMaker cannot recover from a failed deployment. You have to delete the endpoint before you can deploy again. SQL actually don't support uppercase-based parameters for REST call for some strange reasons. So yeah, just some interesting finding. I'll do a quick live demo for our CI/CD tool here. As you can see, this is one of our project in the SQL CI. Besides the unit test, we have other steps for training the model until the deployment. As you can see, in the training step, we have two branches. One is to build the full model, and the other is to use the 100 sampled record to build a sampled model. So when we build a full model, we just build the Docker image and notify the CD to deploy the full model. But when we check in some new code, it will do a sampled model building, and it will actually push to SageMaker directly, just in case anything goes wrong till the end of the deployment. This is our Concurse CD pipeline. We start with triggering the full model building, as I showed, still happen in SQL CI. And SQL CI will notify the CD when it's ready to be deployed. So then the Concurse will take over to deploy to staging. And then we will do regression tests against the staging endpoint. We will do those all kinds of metrics evaluations in the regression test. And after that, we will promote prod. It automatically push to both US East and US West region. We also supported the manual-driven rollback. If you trigger this step, it will roll back to the previous version for both US East and US West. So behind the scene, we actually is using the model registry from MLflow in Databricks. So you can see we started with triggering for version 9. We deployed to staging, and then later we deployed to prod. And then we rolled it back for this version. You can see the version 8 is current prod version. In conclusion, Databricks and its MLflow provided a great environment and tooling for us to run and weave ML jobs with the fantastic tracking abilities. We did some customizations for our enterprise needs and the integration with other tools, as we mentioned, the security concerns and the wrapping logics, etc. In the future, we are looking forward to do more supporting and more automation on the experimental environment, for example, the hyperparameter tuning, feature engineering. So those are still ahead of us. We want to dive more into that. And of course, we want to contribute back our tunings of MLflow to the community so that it can benefit all of us in the future. Finally, we'd like to acknowledge Yong, Andrew, and Liang Yu for their helps. By the way, Yong and Andrew will present more details about the ML model in the coming Spark AI commit. Thanks, Pavel, Yifei, John, and Databricks for the support. We'd like to answer questions in the question answering session. Thanks a lot. Bye.